JA Solar keeps producing and promoting high-performance PV products. Keep innovation and persisting on the belief of customer focus. Keep improving for better solutions and harvesting more sunshine. Integrated with the belief of high efficiency, reliable, and environment-friendly, JA Solar launched Deep Blue 3.0 modules with lower LCOE, but creating more customer value. Deep Blue 3.0 adopts 182mm large sizing wafers, which brings higher power generation benefits. The gallium doping technology has been fully deployed, which effectively mitigates the initial light-induced degradation, LID, and ensures high effective and stable power generation performance. The new generation Perseum Plus cells significantly improve power generation performance under high temperature operation environment and low irradiance condition power generation performance capability through optimized cells front and back service with passivated workmanship. And the mainstream mass production conversion efficiency of the cells can reach up to 23.3%. The optimized 11 busbar cell design shortens the current transmission distance, reduces the cell internal resistance loss, fully improves cell conversion efficiency, reduces the risk of micro cracks, and enhances product reliability. Deep Blue 3.0 adopts advanced module encapsulating technology, optimized high-quality encapsulating materials, half-cut cells series parallel structure, and the mainstream mass production efficiency could reach 21.1%. Diversified types of solar module design to match with different applications and meet the diverse needs of customers' requirements. Harvest the sunshine. JA Solar strictly focuses on the quality of its products as priority. We try to provide our best products for customers with spirit of excellence craftsmanship in each process and detail, which includes raw materials qualification, module design, manufacturing, quality inspection, and testing. Deep Blue 3.0 embodies the refined manufacturing process, leading-edge technologies, advanced devices of JA Solar. From ingot, wafer, solar cells to modules, JA Solar continuously carries out technological innovations to upgrade product property. Automated, intelligent, and integrated precision manufacturing facilities and excellent manufacturing capabilities proves the premium assurance for product quality. Refined manufacturing process and leading-edge technologies. Diffusion Plus SE, reducing the contact resistance between silicon wafer and electrode and the surface recombination. Alkali polishing, no nitric and no sulfuric acid without environment pollution. Integration of PECVD, aluminum oxide, and silicon nitride coating to improve the coating quality. Integration of laser slotting, printing, bifacial double measurement automatic packaging. Non-destructive laser cutting, effectively reducing micro cracks and leakage current at the cell cutting edge. Automatic overlap welding and automatic packaging facilities improve product quality and production capacity. Automation and intelligence, integrated precision manufacturing equipment and outstanding manufacturing capabilities provide an important guarantee for product quality. JA Solar high-quality products have been qualified by hundreds of technical tests and inspections, such as wet leakage current, hot spot endurance, strike impact, and accelerated aging to ensure high product reliability. Modules with 182 silicon wafer makes full usage of container space, reduced transportation costs, and easy for solar module handover. Harvest the sunshine. JA Solar always follows the principle of customer orientation and helps customers reduce the costs of solar system accompanying with more benefits. With the concept of green energy development being accepted by more people, PV power generation has been paid more attention within recent years. Deep Blue 3.0 has become the valued recognition of global customers for its excellent power generation performance. JA Solar continuously keep technology innovations and products upgrade by providing high quality, high efficiency, and aggressive cost PVC products to our valued customers and lighting up the new era of solar energy with lower LCOE solutions. Deep Blue 3.0 for now and also for future. Harvest the sunshine.
Hello everyone. Good afternoon and greetings from JA Solar in India. My name is Shannon, and today I'll be your host and moderator. On behalf of JA Solar, first of all, I would like to extend my welcome to all the guest speakers and audience to this webinar. And today's topic is JA Solar's next generation solar modules and their impact on levelized cost of electricity. We have great program planned for you today, so stay focused. As a review, JA has managed online sessions several times due to the lockdown caused by the COVID-19 pandemic around the globe. And we have been doing live talks and featuring them with products analysis and technical demonstrations, and also share it to all the participants in the industry. So this time, we have switched the camera to India, which has been a very promising market in the long run. And there is also a lot to shout about in local solar industry in recent years, like from the completion of various solar projects across the country, as well as the drastic increase in solar installation. So today's topic is sufficiently important to the improvement to support and promote the local solar installations. And today we have 5 guests to join me during the session, and we're gonna hear 4 presentations about the current trends and markets in India, as well as JA's premium solution. Apart from that, we will also reserve some time for the speakers to answer any questions. So you're more than welcome to leave the comments and questions in the chat room, and we will collect as many as possible and give you a reply during the question part. Before we start today's session, JA Solar Senior Vice President and member of the board, Dr. Ximing Huang has sent an opening address from China. Let's hear it.
Good afternoon, everyone. I'm Ximing Huang from JA Solar. Thank you all for participating in this exciting webinar. As the COVID-19 pandemic continues to rage across India, we have seen the challenges of dealing with the impact for our employees and customers and our communities. Amid the challenge, we are becoming more and more aware of the importance of electricity in our daily life. We see life-saving oxygenators are not fully utilized because of a power shortage. We see the entire power supply system under great pressure during the pandemic. Proper power supply is needed to promote development of India and help people to recover from the impact of the pandemic. With its abundant solar energy resources, India is uniquely positioned to develop the utilization of PV power. In fact, India is the 3rd largest PV market in the world, with an installation capacity of 10.3 gigawatts, growing its global market share from 3.4% in 2020 to 6% in 2021, despite the pandemic. During the severe COVID-19 crisis in the country in the first half of 2021. Even though interstate travel in major states were banned and most PV installation activities was put on hold, the construction activity of some PV projects located in the remote areas continue. This gives us the confidence to further promote the development of PV industry in the country with our efforts. JA Solar focuses on providing the most efficient and reliable solar modules to the market, and our business span from small-scale residential rooftop to commercial building and larger-scale IPP. In the first 5 months of this year, JA Solar has supplied more than 700 megawatts of high-efficiency modules to the Indian market, which represents about 20% share of the market. To provide the best products and services to the market, we have continuously strengthened our commercial and technical team to deliver best-in-class customer experiences and optimal solutions to our partners and customers. To our valued partners and customers, I want to thank you for your trust and making JA Solar your business partner. Let's work together to further promote the development and the deployment of solar energy in India. Thank you again for joining us, and please enjoy the webinar.
Thank you very much, Dr. Huang. We know that West Asia and Middle East areas enjoy a lot of solar energy resources, which is a unique advantage to make PV more and more competitive comparing to fossil energy. We have also prepared a video for you to help you learn more about the solar installation and development in these areas. Take a look.
JA Solar is a global leader in the PV industry. It has established a vertically integrated industry chain covering silicon ingots, wafers, cells, modules, and PV power plants. With its excellent track record, sound financial condition, and respected reputation in the industry, JA Solar has been listed on Global Top 500 New Energy Enterprises and Fortune China 500 for many years and is rated by Bloomberg NEF as 100% bankable. By the second quarter of 2020, the company's cumulative shipment has reached 50 gigawatt, taking around 8.5% in the global market. It has kept the #2 position in global module shipment rankings for 2 years. While focusing on the company's development, JA Solar has a strong social commitment to help those in need. It has made donations to establish schools to help people fight against diseases and has donated PV power systems to help people in remote and desolate places to solve the problem of power shortage. Being devoted to the research and development of high-performance PV products, JA Solar has constantly made breakthroughs and achieved new milestones to become a global leader in the PV industry. By 2019, the accumulated shipment of its high-efficiency PERC product has reached 13 gigawatt. It is the first company to manufacture all its modules with PID-resist technologies. Now, JA Solar has 12 manufacturing bases, over 33,000 customers in more than 120 countries. And the company has established strategic partnerships with leading local and global corporations in the industry. It has supplied modules for PV projects in developed PV markets, including the US, Japan, Europe.
Okay, so without further ado, please welcome our first speaker, Mr. Monsoon Wang, the Global Marketing General Manager and Senior Product Technician of JA Solar. He's been dedicating to the development and the decrease of LCOE. So please, Mr. Wang.
Good afternoon, ladies and gentlemen. This is Monsoon from JA Solar. So it's my pleasure to share some information about JA Solar's latest module product with you. So today my topic is JA Solar Deep Blue 3.0 with 182 millimeter wafer, which is premier solution for the best LCOE. So my presentation consists of 3 parts. The first is a design idea of this Deep Blue 3.0. The second part is the technical highlights of this product. Finally, we will do some value analysis of this product. So this picture shows the module power improvement trend roadmap during the past 10 years. We can find from this picture that the module power output is increasing very fast during the past 10 years. So you can see that 10 years ago, it's just the main power output of the PV module is just over 300 watts, but till now it's the main power that is almost higher than 500 watts. So we analyze why the module power is increasing so fast. So first, the reason is cell efficiency improvement. So we can find that during the past 10 years, the mono cell efficiency increased from 17% to 27%. So also the mass production of PERC technology has boosted the cell efficiency greatly. So the second is about the improvement of the module encapsulation technology, such as AR coating application of AR coating glass, the silicon ribbon, the high transmission EV, and also the including the half-cut cell and multi-bus bar, etc. And also recently some new encapsulating technology such as single module paving high density has also emerged in the market. So finally, another important reason is the wafer size or the cell size is getting bigger and bigger. So many years ago, from the 125 millimeter, gradually expanded to 156.75 millimeter and 166. Nowadays, the mainstream is 182 and even some 210 in the utility scale product market. So let's make a basic analysis between the relationship between the BOS cost and the module power output. So from this picture, you can see that when the modules have the similar efficiency, when the module size gets larger, the BOS cost will drop significantly. But however, you will also find when the module gets big enough, which means the power is high enough, you can see this trend is getting slower and slower. So when the module power is over 500 watts, you can see that when the module gets even bigger, you can see the BOS cost will drop slowly in the future. So also we analyze the relationship between the module efficiency and the BOS cost. You can see that with when the efficiency when you get higher, you will get lower BOS cost significantly. So you can also see from this picture, you can also find that efficiency contributes more than compared with the module power output. So it's also a key issue topic for the PV module manufacturer to increase the module efficiency. So another topic is the module, PV module is the module, the larger, the better. We think it has some limitation. So oversized module doesn't contribute more BOS cost, as I mentioned before. So if you make the module size bigger and bigger, you will face some potential risk, such as mechanical load risk, transportation. It will also get some more difficult for the transportation and installation, and it has some, gives you some more challenge to the structure loading capacity. So we think that nowadays the big module has already reached the bottleneck for the market. So we will focus more on the efficiency improvement. So another topic is about the relationship between the voltage and power. So as we all know that power equals voltage minus current. So when you get higher power output module, it means that you will get higher voltage or higher current. So everybody knows the low voltage can save the string can adjust string capacity and decrease the system cost. But we have to analyze the, the risk from the larger current. So we did some analyze on the large current impact on the large current. So first you can see when the current gets larger, the CTM loss will get larger. So which means module cost will increase. So also when the module current gets even larger, so the operation temperature, the internal resistance loss will get higher, which means that it will increase the module operation temperature and will drop the module power output. So higher current also gives some risk on the connectors and junction box diodes. So we did some, simulation during the field test. So you can see that in the high readiness data, due to the higher internal resistance loss, you will get resistance loss is higher when the current gets higher. So we should analyze the relationship between the current and the resistance loss. So that's that's the logic of JA Solar's module design logic. So this size, we think the module should have reasonable size, reasonable electric parameters. So we focus on the best LCOE. So the module size also of the wafer, the module size and the wafer size is determined by the whole industry chain, including production, installation, transportation, and solar system configuration. So this is a design idea of JA Solar's Deep Blue 3.0. In order to get some more information, some more data on the module energy yield performance, so we did some cooperations with JA Solar with TUV Nord. We conducted 1 year field test plant at the National PV Experimental Center in Incheon. So now that we have got almost half a year data, I will show you some data. So first is the relationship between the module operating temperature, and the module current. So from this picture, you can see that compared with the high current module, JA Solar's Deep Blue 3.0, the average working temperature is about 1.7 centigrades lower. So the maximum gap is about 4 to 5 centigrade. The main reason is I mentioned due to the internal resistance loss. Also, we can find that from the energy yield performance, we can find JA Solar's Deep Blue 3.0 compared with the ultra current module. The energy yield is about 1.8 higher per watt. So it shows we have the Deep Blue 3.0 has better energy yield performance. So also, this Deep Blue 3.0 has awarded TUV Greenland's All Quality Matters Award in this May. And for the TUV North side, we also obtained the TUV North Outdoor Yield Performance Award this year. So second part is the technical highlights of this product. So as I mentioned, this product is based on 182 millimeter wafer and half-cut cell technology. So we also adopted gallium doped wafer in this product, and we use this 11 bus bar design to make better energy yield performance and better reliability performance. So we have upgraded perfumed PERC cell in this product, which we call perfume. It has better, it has better long wave strength, long wave generation, and we think that it's about 2 and 3 power generation performance compared with the previous generation cell. So JS Solar is the first module manufacturer adopt gallium doped wafer in the mass production line. So gallium doped wafer brings lower LID in the first year. So we guarantee the annual degradation in the first year lower than 2%. So we also adopt 11 busbar, which improves the cell efficiency and the module increase the module power output and brings better reliability performance and also brings more higher energy yield performance. So hub technology is very mature. We are adopting our mass production line. So in order, it also drops the hotspot temperature, module working temperature. So this is a Deep Blue 3.0. So you can see that we have a very excellent working temperature coefficient, and we have a very excellent degradation performance. So we have a series of products either for the residential or commercial rooftop and the utility scales project. So we also launched our next generation Deep Blue 3.0, which we call Deep Blue 3.0 Pro in Snap this year. It uses gapless flexible interconnection technology, so which will bring 10 watt higher power output and about 0.4% module efficiency improvement. So this product will be, we think will be the mass production will be in the beginning of next year. So finally, let's do some brief value analysis of this product. So first, we did some cost comparison on the fixed structure. So you can see that compared with the 166 module, so 182 module has very, dropped the BOS cost significantly, and also compared with 210 module, so we have very similar BOS cost saving in the system side from the system side. If we applied it in the single access trackers, you can find that 182 mm wafer module has better BOS cost saving performance from the tracker side. You can see that even compared with the 210, the tracker system cost saving is almost the same, or even some better, even better. So we also did some project in Dubai, 100 megawatt project. So we did the BOS cost comparison and the LCOE comparison, as I mentioned before. So since this product brings a significant BOS cost saving, and it has very excellent energy yield performance, so we can see that JS Solar's Deep Blue 3.0 is the best solution for LCOE at this moment. So it's a premium solution for LCOE for utility scale project. Okay, so that's for all my presentations. Thank you very much.
Okay, thank you, Mr. Wang. JS Solar released the white paper together with other two companies last month, has demonstrated the advantages for developers of large-scale PV projects of using 182 millimeter wafers, which is the most cost-effective solution based on the in-depth analysis of various boundary conditions. Just like Mr. Wang just said, the simple adding of the size of modules will not only increase the large module size power. So I guess bigger is not always better. Now please welcome Mr. Alex Lee from Sungrow. He's the technical director of Middle East and North Africa region. And today he's gonna talk about the inverters and its special applications in India areas. So please, Mr. Alex Lee.
Thank you for your host. Hello everyone, this is Alex from Sangro. I'm in charge of the PV and the ESS part for Sangro MENA region. It's my great honor to be here working with the JA Solar. Today, I would like to talk about how PV inverter adapt to the large format modules. I'm sure you are interested in this topic because of the major PV module manufacturer has launched the new era of large format module since the last year. Today, my presentation includes three parts. First, the innovation trends of PV module. Second, the new technology of PV inverters. The third part is a Sangro system solution to adapt to the large format modules. Okay, in the next page, I will introduce the innovation trends of the PV modules. Just like Monsoon said, in the past 5 years, the module power kept increasing every year, and it was proved to be the most efficient way to reduce the system cost. From this table, we can find that from the 300 volt module to 400 volt module, the system cost was cut down dramatically in terms of the low cable cost and mounting system cost. I believe that the new era of 500 volt plus modules would bring further cost reduction. At the same time, it will also bring some challenging to the balance of the system, such as the mounting system, DC cable, string design, and the PV inverters. For the new era of 500 volt plus module, now there are two main technology roadmap by using different PV cells. One technology is using 182 millimeter PV cells, which is featured with the high voltage, while the other use 210 millimeter PV cells, which is featured with the high current. We can easily understand this two roadmap by the formula power equals voltage times current. So JA Solar is a representative manufacturer of high voltage roadmap. For the high voltage modules, the MPPT current never beyond 15 ampere. Sangro current central and string inverters can match it well. For the high current modules, the MPPT current is higher than 50 ampere. Sangro has updated the fields of the central solution, the combiner box, and the MPPT current of the string inverters. So now Sangro both central and string inverters can handle with the high current, the 50 ampere and the 20 ampere input. When all the system equipment are ready, the system design is important. As an inverter supplier, we never say which technology roadmap is better than other without a specific project requirements, because there are too many factors which can affect the LCOE. In the other word, both PV modules has their advantage. If the performance ratio is more important for the project, the high voltage module can bring a lower cable cost and mismatch loss. Based on the left configuration, the conclusion is confirmed. Before choosing the PV modules, we need to do the overall consideration, including the capex, energy yield, and some other factors. In the second part, I will introduce the innovation trends of the PV inverters. As we know, the PV inverter is one of the most important devices of the PV system because it will affect the system cost and grid connection a lot. Definitely, Sangro is a PV inverter manufacturer, but we always consider how to improve the whole system as the direction of our innovation. So I think this is the secret why we always stand in a leading position in this industry. You must be very clear about how PV inverter influence LCE of a project. We know a suitable inverter model can bring lower capex, OPEX, and a higher energy yield. But today I would like to highlight the AC side of the inverters. That is the grid support and reliable connection. If you see the graph from the on the right, with more and more renewable energy connect to the grid, the renewable energy become the main part of the grid. Therefore, PV inverter must provide robust support and faster response to the grid. And how to combine the PV and the ESS together is also a trend of the innovation of the PV inverters. Sungrow Central solution, which is a container turnkey solution, it contributes a lower cable LCOE for the DC side. The data logger is already inside in the inverter, which can connect all the data from the PV field, including the tracker, which will make the OM work more efficient. Also, the PV inverter is a double direction converter, which can accept a DC coupled. From this year, more and more project buying request the PV inverters to have the energy storage interface. So from the AC side, the Sungrow inverters can provide the faster response and adapt to the grid, weak grid. This makes us more competitive in the project bidding. Next, I want to introduce one of the Sungrow patent technologies here, called self-constructed grid function. It means the PV inverter can do hot commissioning without grid. The power is from the DC side. This function can shorten construction period at most. For the project which is located in the complex terrain or a very remote area, Sungrow would suggest to use the string solution. This SG250HX is a very competitive product in this market. We just won the Oman 500 megawatt project, Qatar 800 megawatt project, and Abu Dhabi 1.5 gigawatt project by using these string inverters. So it's very popular. Sungrow patent PID recovery function is standard integrated in the inverters. This function can bring more energy yield and can save AC cable cost for the TN grounding system. But some other supplier doesn't have the PID solution and also cannot support the TN grounding system. So that is one of our advantages. Sungrow string inverters. Sungrow string inverters with the Sungrow monitoring platform can provide online IV curve scan and analysis report for free. We did some tests in a real plant for 100 megawatt utility plant. We can finish the scanning and provide the analysis report for the whole plant within 10 minutes. That is very fast and very convenient. In the last part, I will introduce Sungrow typical system solution in the MENA region. In this slide, this slide shows the mainstream and the new generation inverters of Sungrow. We usually recommend our customer the central solution, the central inverter in the flat project because of the lower system cost and the greater support functions. And we always propose the string inverters in the irregular plant because of the easier maintenance and more MPPT. The central solution including SG 3125HV-30 and SG 1100UD-20, while the string solution including the SG 250HX, just as I said, and the new generation SG 320HX. The latest central solution SG 1100UD use the modular design with a flexible block capacity, for example, 3.3 megawatt, 4.4 megawatt, and up to 8.8 megawatt solutions, which is very convenient for the customer. This diagram is the typical system solution for SG 1100UD in the MENA region. The block capacity is 8.8 megawatt using a standard 40 feet container solution including 8 units of SG 1100 UD, the MV transformer, the remand unit, the auxiliary power, and also the communication part. So which is a highly integrated system and can saving the site installation work at most. SG320HX is the Sungrow latest string inverters with the largest output power in this industry. The recommended block design is 8.85 megawatt, which can get a lower LCE. Each MPPT only has 2 strings as per the AEC 62548 standard, making the inverters more safety. SG320HX can also work in the weak grid when the SCR is low to 1.16, has a better grid support functions. This slide shows the diagram of the system solution of SG320HX in the MENA regions. The block design capacity is 8.85 megawatt. There are 30 units of SG320HX connected, which will connect to the MV station. The MV station is a standard 20 feet container solution, also including the MV transformer, the remand unit, the auxiliary power, and also the communication part, which is also highly integrated and saving the site installation work also. In the past 5 years, Sungrow inverter shipment capacity grew up more and more. We are always the global leader in the industry, in the inverter industry. Until now, more than 182 gigawatt Sungrow inverters has been installed in the world. Our customers are coming from more than 150 countries. We have established more than 200 service outlets. These numbers are significant. 182 gigawatt is a milestone to Sungrow, just like JA Solar insists on the 182 millimeter wafer. According to the inverter bankability service results from Bloomberg, Sungrow take #1 again in 2020 in award. Sungrow is the global leader in this industry, which is trustworthy. So that is all of my presentation. Thank you very much.
Okay, thank you very much, Mr. Lee. Sungrow's products enjoy a very good reputation in the industry, and we know that customers always require a lot on the products from a certain link, but actually higher integration and compatibility of the whole chain can better guarantee the power generation result. So now please welcome Mr. Himanshu Sugandhi, the Business Development Director from Nextracker, to talk about the large PV modules and solar trackers. He's been in the industry for 10 years and providing functional expertise in the business development and strategy. So Mr. Sugandhi, please.
Thank you, Shannon, for inviting us to this, and thank you, JA Solar team, for having us here today to talk about these large format modules and how they impact, the trackers and in general the overall power plant. I would just like to check if you're able to see my screen here before we get started now.
Yeah, it's fine.
Perfect. Thank you. Very quickly, a quick snapshot about Nextracker, who we are. Nextracker, as most of you know, is the global market share leader in the solar tracking space with over 12.8 gigawatts shipped in 2020. We are roughly maintaining about 30% market share for about 6 years in a row with a leadership position in the space. Nextracker is a company owned by Flex, a $26 billion corporation, so a very bankable entity. We have about 450 staff worldwide in 8 global offices, including our headquarters in Fremont, California. In terms of our product offerings, we are focused on the solar tracker and software and control systems for those solar trackers. So that's a very quick gist about Nextracker and who we are. Let me touch very quickly about our portfolio offerings that we have. So Nextracker has a strong tracker product portfolio comprising of two key products, the NX Horizon and the NX Gemini. The NX Horizon is our legacy one in portrait configuration, um, uh, which been launched in 2013. So it's a legacy product, well proven from Nextracker. NX Gemini is a two-in-portrait tracker configuration launched towards the end of 2019 and currently in the initial days of its deployment worldwide. Apart from the Trolla tracker offerings, Nextracker also has very smart software control systems offerings comprising of True Capture and Navigator. Now, these are smart software control platforms which basically enhance the yield of the power plant by up to 6% and also enhance the monitoring precision of the whole power plant. Along with that, Nextracker offers a range of data and monitoring control services for its tracker systems that help improve the overall asset efficiency when they're operating. A very quick snapshot about Nextracker's presence in the MEAT region. This is the Middle East, India, Africa, and Turkey region. We have roughly about 3 gigawatts of projects in the region out of the global 50 gigawatts that we have worldwide. Now, let me dive right away into the topic that we've been discussing. The earlier speakers, Mr. Wang, Mr. Alex, talked a little bit about how that's impacting the overall systems, and we would like to talk about how these larger formats really affect the tracker design, the tracker the tracker installation and things like that. As some of the speakers talked about, historically we had the 156 to the 156 cell modules. The rate of change was much slower, so there was not much change in the dimensions of the module. There was a really incremental changes, and the efficiency more or less was pretty much around the same mark. However, over the last year or so, we have now seen two key trends emerge with the 182 wafers and the 210 wafers. So those are the current trends that we are seeing in the module space or the wafer space, which is impacting modules. And of course, this is really driving an array of module configurations. Modules tending to become bigger, wider, and more heavier. So that's basically what matters to us as structure providers. So what are the implications on the racking system when we talk about these larger modules? Obviously, as we talked about, with the bigger wafer, the size of the wafer increases, the module size increases. We now see an array of module sizes. The areas are now over 2.59, 2.6 square meters. What does this impact on the tracker? So of course, the larger module really means that there is more torque required to now really move the module in the east-west direction as it's tracking the sun during the day. It also requires that the modules and the structures are able to withstand higher static and dynamic loads, because now a larger area is exposed to winds and the elements. So obviously the loading requirements are increasing, and that really impacts the mounting mechanism that we deploy. It also deploys, increasing the strength of the components like rails and other parts. The other change that really happens is as these modules become bigger, they also become heavier, right? You have a bigger glass, they're more heavier, which in turn also implies that now we need more steel, more hardware going into the mounting system to actually make it more robust and be able to hold these larger format modules. Also, as a couple of the speakers earlier pointed out, the bigger module is obviously going to take more installation per module, because now you need more people maybe and maybe more time to actually install these bigger modules. So it kind of impacts those things. We've always partnered with reputable suppliers like JA Solar on their products, and always working in anticipation of these emerging trends in the industry. So how do we as tracker suppliers go about this? So obviously, as these modules become larger, we go and go back to the drawing board, do the wind tunnel test again. We reassess, reanalyze the impacts on the structural design based on the increased module lengths and widths, We look at the impacts on the pier spans and the tracker lengths, how big the tracker needs to be able to support these bigger modules, right? So those are some of the wind tunnel assessments that we already do as we come across these bigger modules. Now, one of the things that happens is that as the modules becomes bigger, they're exposed to more dynamic modes, which can then cause instabilities in the structures. So as the area exposed increases to the wind, the trackers and the systems can set into dynamic unstable modes at lower wind speeds. And in order to prevent that, we really need to go and analyze all these responses of the tracker with the bigger format modules. Nextracker continues to work with reputed wind tunnel agencies like CPP to ensure that all these modules, their dimensions, when we are working on them, are tested, and we have a robust product offering from the tracker side. We also take pride in that we partner with companies like JA Solar in doing joint testing of the module. So not only are we ensuring the theoretical design works, we also then take out these modules, do a lot of fitment and loading test on the modules to evaluate how these modules are behaving with the bigger modules with the tracker, to demonstrate that the overall system is tested. So it's not just tracker or module, it's the combination of tracker and module that is tested to ensure the overall compatibility between the trackers and the modules. Let me touch very briefly on some elements of using a robust module, why that is important from a mounting structure standpoint. Is one of the things that we see when we are doing the tracker designs for a project is that the wind pressures on the module will vary between 2x to 4x given in a site. So depending upon where the modules are going to be placed, it's in the exterior zones, interior zones, they will be exposed to varying wind pressures. And so if the module itself is not designed properly or it's undesigned, it basically kind of passes on more mechanical support. It needs more mechanical support to really pass the load test, the desired levels. For instance, if you have a robust module, say instance J Solar, then the kind of mounting that the tracker system would need would be like a light to a medium kind of a mounting, and with a good frame that is supporting the module. Whereas if we look alternatively at some of the weaker modules that we come across occasionally, the module is not very robust, and so it has kind of a penalty on the mounting structure design, because now we need to do more heavy mounting on the tracker side, which kind of creates a penalty because of the weakness of the module itself. So we encourage to look at the quality of the modules also when we are looking at these larger module formats. Definitely look at reputed players like JA Solar and likes. So here is a very quick gist from the tracker perspective that we see. Obviously, the large format modules are benefiting because now you are able to get more power per tracker row. So that's causing like a 17% improvement there compared to a standard 166 mm wafer. You also have more power per tracker area, which means your power density has improved, so you need less area. This is just the impact on the tracker. You obviously have some other downstream impacts coming in because of this. Now, because of the bigger module, you now need 18 to 20% less labor to actually install those systems now, because the quantities have reduced. You are having to install almost 15% lesser foundations. So that's saving on your other items that you see. And overall, you will find savings on the wirings and cablings because of the bigger power module. So obviously there will be those impacts, and it's obviously creating improvements on the LCOE basis on the overall system. I would like the participants today to also refer to the additional resources on our website. At the resources section, there is a lot of literature about how these bigger modules, what are the kind of impacts that they need to withstand with the tracker design, and a lot of literature around there to go in detail of this topic. Thank you so much for providing us the opportunity today. Thank you, Sharon.
Okay, Thank you, Mr. Sugandhi, for giving us such a thorough introduction about Nextracker and your solutions. So now it's time to hear something from the certification organization. We have invited Mr. Joseph Nader, the Solar and Commercial Product Division Manager from TUV Rhineland, to share something about the trends and challenges for large-size PV modules. So, Mr. Nader, why don't you take it away? Mr. Nader, please turn on your microphone.
Okay, now can you hear me?
Yeah, sure.
And you can see my screen as well?
Yeah.
All right. So thanks, Shannon, and thanks, JA Solar, for this invitation. It's a pleasure to be part of this discussion. My name is Joseph Nader. I represent UV Rhineland for the MENA region as a business development manager and responsible of the local division here. Basically, I didn't include in my presentation an introduction of the company, so just allow me 1 minute to go through what we do as UV Rhineland. So the company has been established almost 150 years back. It has different divisions. So I represent the solar energy division, and as a solar energy department, we were established back in the late 70s, early 80s. Back then, our trip in the solar industry started as testing and certification of modules and cells. And then later on, almost around the beginning of 1990, we included the consultancy for PV power plants. And currently, we have a couple of labs around the world where we do testing, certification of not just modules, but as well different components related to the solar industry. And our team globally in the solar field is around 250 people. And we have labs in India, in Bangalore, in Shanghai, China, and in Cologne, as well as in the States. So coming back to the topics, trends and challenges, I would like to just focus more on the side of the lab testing. So what we are facing in the labs and what are the matrix that we see in the labs, especially related to these new edition of solar modules. So a very short overview coming back to the early production years of 1968 and the first 2 years up to 78. So the first module were quite small, and we're talking about cells that are 10 times 10 millimeters and an overall length and width of let's say 0.5 times 0.5 meter. So gradually the modules got bigger and bigger, and the cells went from the wafers from being cut as rounded to quadratic. And around the late 70s, we saw the biggest modules coming from General Electric, producing around 100 watt and 72 cells. Again, 10 times 10 millimeter size of the cells, and the overall size was around 1.2 meter times 60 centimeter. So this is a kind of like the early stages where these modules were marketed, and then they were available as well to be sold on the market. And this is as well where we started the lab in Cologne in Germany and to do certain tests. And gradually we saw an evolution of these modules, and mainly around 2010, where the size of the wafer or the cells got bigger. So now we are talking about 125 times 125. And then in the same year, later on, we saw bigger cells, actually much bigger. So we're talking about around 20% increase in cell size to 156 and 156. And this is where the challenges started, because the modules got bigger, and as well, so the energy need of these modules got higher, and additional tests needed to be done. So what we deal with in the lab are mainly the standards IEC 61215 and 61730. And the initial standard edition were from 2005. And then there needed to be an upgrade for these standards. So moving forward in 2010 towards 2016, the increase in energy efficiency was, I would say, more or less stable. So mainly 72 cells were found on the market, of course 60 as well. And as an average, the cell size was 156 times 156. Now in 2017 and 2018, we saw different technologies coming to the market. So we moved a little bit from monopoly N-type and P-type towards PERC and half-cut cells. And currently we are with bifacial modules. So all of this increased the power output and power rating of these modules, and not just the size of the cell. And what we see currently on the market are mainly cells around the 182 millimeter. And we might as well see a trend moving forward of cells around 210 millimeters. So all of these different modules and sizes coming to the market added challenges. And if you want to talk about these challenges that we face in the lab, maybe we should focus our discussion then in this case around the topic of module design. Of course, component design is has a big effect because these modules are at the end just a combination of different components. So the cells, junction box, backsheet, glass, and frame. So if these components are well put in place and well combined, then we need to talk about how the behavior is on the module level. And then we have the reliability, and we a little bit touch upon the 61215 and 61730. Currently, we are in the edition 2016. So we see that from the previous slide, that it took almost more than 10 years to have this new edition. So it came around 2016, whereas the new type of cells and new type of modules were already since more than 5 years in the market. So having an updated standard is a slow process, and for these standards to be out. And therefore, at the end of my presentation, I would want to recommend additional tests until the standard is renewed. So currently we are as well, lately beginning of 2021, we have the 61215 edition got updated, taken into account some of these larger modules and additional tests, but we will touch upon this a little bit later on. So moving forward, I would like to focus now on the module design side. So that would include circuit design, the distance between cells, and the number of cells, especially when it comes to the bypass diode. So again, from a lab testing perspective. So one of the standards that regulates the revision of tests based on changes in module design is the 62915. And this was published, or let's say the new edition was published in 2018. And we get often lots of questions from many manufacturers that I only changed the cell size, or now my cells are more efficient. Why should I do additional tests? What type of additional tests should be done? And this table basically shortlists what type of tests are required based on certain changes in the BOM, bill of material of the module, even though that the overall concept of the module remains similar. So for instance, if only we have a change in the distance between the cells, so now we discussed how the cells are getting bigger and bigger with time. And if the same module, everything is similar, just the distance between these cells got changed in the module design, then certain tests need to be redone. And for instance, the thermal cycling and the reverse current overload. And mainly these tests are put in place by the standardization committee to make sure that the addition or the changes in the module design is still abiding to the overall quality perspective and energy yield output of these modules. So I'm not gonna go into details for all these points, but I'd just like to touch upon the couple of points. For instance, the cell size. And here we've seen that the cell size is getting bigger, and not just bigger, but as well in certain instances, these cells are more efficient. and as well we have a higher number of cells in series and in parallel, which means overall that the power output of these modules is getting higher. Of course, we're talking about short circuit current and open circuit voltage as well, which is increasing the stress, not just on the cells, but as well on different components in the modules. Some of these components are, for instance, just before touching on the components further on in the module design. As mentioned before, we have cells getting bigger, and in order for manufacturer to keep the module size more or less small, some manufacturers are tending to put the cells closer to each other. And in some instances, we've seen modules coming to our lab with the cells being really touching each other. So after lab tests, and mainly after the thermal cycling and damp heat, we've seen cracks propagating in these cells, especially in the areas where the cells are touching each other. And this would be a reason enough to make these modules fail the test. This is one aspect that needs to be taken into consideration. So the more we tend to put cells closer to each other, the more we are tending to raise the power ratings of modules with higher efficient cell, the more stress is put as well on the design side, especially as well on the cell side, resulting in cracks. So here again, moving forward with the cells, but talking more about touching on the topic of shading. And shading is a huge topic, especially if we have some of these larger modules are mostly currently placed on rooftops due to reduced area, or let's say if a rooftop owner wants to have a higher output out of the rooftop or the area of his building, then these investors are tending to increase the power output of the module and purchasing higher rated module. And often these rooftops are in areas that can be shaded, and which is resulting on higher stresses, not just on the cell level, but as well on the entire modules. So from some of the tests conducted in our labs, we have seen by shading some of these cells, a quite high temperature focused as well, not just on the front part, where you can see here that the cell is burned, but as well we have seen bubbles forming in the backsheet of the modules. So moving towards a higher efficient cell and bigger modules, especially in shaded areas on rooftops, can be dangerous, and therefore we can provide certain recommendation when it comes to installation. And certain advanced testing especially for shading. Again, within the topic of module design, bigger modules means that an additional stress is put on the glass, on the framing, and one of the failures we've seen recently, I mean, I would say in the past 2 years, occurring more often, is module breakage. So one of the tests based on the standard is mechanical load test. And as you can see here, so this is basically a typical mechanical load testing equipment on the left side, and on the right side, you can see that these modules, or let's say some of these modules in the initial stages of their production got broken. And here as well, the investors need to make sure that if they are tending toward investing in big modules, all of these tests, even additional stress. So in a sense, additional stress in this case means applying additional upward and downward force on the module, that these modules would withstand additional stresses. Again, within the module design, I would like as well to talk about shading, but this time shading coming from the junction box itself. And here we're discussing bifacial modules. So what we've seen in certain instances, a drop in the short circuit current and as well in the overall IV curve. As you can see here, there's a current mismatch between cells. And this is due mainly, or actually it's only due, we would say, to the fact of having certain areas on the backside of bifacial modules being covered by junction box and by cables. So this is as well an area that needs attention when purchasing modules, and moving forward as well for manufacturer when producing bifacial modules, where to place the junction box and how to conduct the cables. So away from the module design, if you want to dive a little bit into the component segment, again, there are many points here left away, but there are, so a module is composed of even further elements besides the ones listed here. But in our case, due to time, we will limit ourselves just to a couple of these points. So the glass and the framing was mainly discussed before, and we've seen failures happening in the mechanical load tester. But now when it comes to solar cell, junction box, and backsheet, we have a couple of examples, again, from our lab. And here you can see that with most of the manufacturers are still using the same component as before. So in a sense, they are using the same component as with lower rated modules. So although we've seen that the larger modules bring about 10 to 20% additional power output, some of these manufacturers are still using component from older modules. We're talking about diodes, we're talking about cables, and as well from the design side, the distance between the cells and the junction box and the framing. So overall, there's a higher increase in short circuit current, and then this needs to be accounted when it comes to the bypass diode. And as well, we've seen some failures happening while testing connectors. Especially now we're talking about the higher rated modules and EV modules of larger sizes. So one of the tests is reverse current test. And in this test, we have seen many modules reaching extremely high temperature. And we're talking about temperature beyond 90 degrees Celsius. So this picture shows a module reaching temperature of 92 degrees Celsius. And of course, this adds up high stresses on the junction box and the diodes, but as well, we can see here the connector that is as well reaching temperature beyond 90 degrees. And this needs to be taken into consideration. So all of these tests are part of the IEC standards, so nothing is out of the usual. So these usually the temperature reach in known modules that have been in the market since a couple of years, lower energy yield output are usually somewhere between 50 to 70, but now we're seeing temperature reaching beyond 90 degrees. So this is as well part of the reliability, and with a higher short circuit current and with a higher open circuit voltage, we are seeing a higher reverse current and stresses on the diodes, leading to higher leakage and higher temperature of the diodes, and this needs to be taken into account. Now, when it comes to reliability, we touched a little bit upon the actual standard, and I mentioned that usually standards take time to be updated. So, for instance, both of these standards took around more than 10 years to be updated, and we saw the 2016 version. Although new technology was in the market since 5 years, so it took them more than 5 years to update the standards to account for certain additional tests. And we as well think that there will be some delays before a new edition of these standards appear, taking into account the higher rated modules and bigger modules. So, and as well certain aspect of bifacial modules. So when it comes to reliability, different aspect need to be taken into consideration. So for instance, when we are talking about installation in a mild environment, then probably the standard tests are okay. But then, as mentioned by one of the presenters, a higher emphasis needs to be put in place when it comes on the trackers and mounting structure, if they can withstand additional load from more or less a similar space and area. And when we are talking about the rooftops, so the size of the rooftop is fixed, but then when adding additional load within the same space adds up as well additional load on the structural integrity of the rooftop. So this is when it comes to the system sizing and leveling. When it comes to bifacial modules, again, when we have shading, and we've seen picture of burns in cells and in backsheet. So when we have shading on bifacial modules, again, this adds up additional stresses on the overall electrical circuit and the module itself, and this needs to be taken into consideration. Now, for our region, I would say, let's say the MENA region and maybe Africa, where we have lots of desert and high temperature, again, as well, like in India, certain region, high humidity. So the modules are definitely put under additional temperature stress. And accounting to this additional, I would suggest, or let's say the testing inspection companies suggest additional tests that needs to be done in a lab environment and outdoors before exposing these modules for 20 or 25 years to such environments. Now, if you want to talk about cold region where we see lots of snow load, definitely additional mechanical load test needs to be done in the lab to account for these additional loads coming from snow. So this is when it comes to reliability. And with that, allow me please to conclude. So in general, we are seeing a trend for sure. So there's a trend towards bigger cells, bigger modules, higher efficiency. The question is, are these modules tested enough? And not just in the lab environment, but as well outdoors. So most of these modules are in the market since, let's say, 1, 2, maybe 3 years. So we don't have enough information coming out from the field. Therefore, it is highly recommended for investors to do additional lab tests before purchasing high-rated modules. And then, as again, if you want to discuss or touch upon certain topics, for instance, encapsulation and packaging and shipment. So these are as well topics that needs to be taken into consideration. Again, when modules are stacked upon each other, having higher weights, so this adds up load on the modules on the end of the stack. Or let's say below in the stack, and then shipment might as well be an issue because, as mentioned before, we do on-site testing and we do EL for lots of power plant, and we've seen in our post-shipment inspection, some of these modules having already being shipped already with crack or arriving with micro cracks, and this can be seen to the EL electroluminescence tests. So definitely there's a trend, and I would say there is no need to be afraid of this trend because it is good for the market, and it's good as well for the investors, as mentioned as well by some of the presenters, for the levelized cost of electricity. But then we would suggest that additional care should be taken for quality assessment and quality control measures, especially supply chain tests. And with that, I would like to conclude. Back to you, Shannon. Thank you.
Thank you, Mr. Nader, for your sharing. Very insightful. And that brings the end of our presentations. And now we'll enter our question part. Before this session, we have collected some questions. And the first one is actually for Mr. Nader. How do you see large size modules in terms of performance and reliability? And from the perspective of industry development, what are the main difficulties in the application and adaptation of large size modules?
Yeah, so I mean, definitely we are seeing a trend, right? So the last 2 years, we're seeing that this trend is here to stay. So the modules cells are somewhere between 180 to 10 millimeter, and more manufacturers are moving towards producing bigger cells, and with that the modules are getting bigger, and the efficiency is getting higher because everyone is asking for higher efficiency, and so this trend is here to stay. And now we need just to take care more about the quality side, and we can do that by including additional tests and by updating some of the tests in the standards, plus by including certain supply chain quality assessment, quality control measures. So just shortly to answer now your question, I believe that the trend is going this way, and the modules, we have lots of good modules in the market, so there shouldn't be, investors shouldn't be afraid of applying these modules. I'm just saying that they should take care of quality assessment before certain purchases.
All right, thank you. The next one is for Mr. Monsoon from JA Solar. How to achieve the balance between increasing the size of silicon wafer and reducing the BOS cost? Mr. Wang?
Yes, in order to get the balance between the BOS cost and the module power output, so you should consider about the whole industry line. So first from the PV manufacturing side, you should get the best manufacturing cost. And also you should consider about as a transportation and installation and the system configuration, system adaptation. So compare, for example, if the size is too big, maybe the power output is big, but maybe it's difficult for the manufacturing side. You will get higher manufacturing cost. Also, if the module size the wafer gets too big, the module size gets too big. So it will bring difficulty for the transportation installation side. Also, from the system side, you should think about system adaptation of the inverter, of the string loss. You should think about all for the industry line. So that's why we analyze the whole industry and analyze from manufacturing side, installation, transportation. So that's why we choose JA Solar's Deep Blue 3.0. Our concept is a module should have reasonable size, reasonable weight, also get a well balance between BOS cost and from the module power output. Okay.
All right, very impressive. So the next one is for Nextracker. Mr. Sugandi, what is Nextracker's experience with bifacial modules, and what kind of energy gains does bifacial module provide on trackers?
Surely, Shannon. So Nextracker, has been a pioneer in the bifacial technology, adopting the bifacial technology on the trackers. We've been working with bifacial modules since 2017, when we started doing the first projects with bifacial. As on date, we have close to about 12 gigawatts of bifacial product installed on Nextracker trackers worldwide. In terms of efficiency gain, it really depends on the site conditions, the albedo. But we've seen, it kind of varies anywhere between 6 to 14% on the bifacial gain that we see. So on an average, I would say about 7 to 8% is what we typically see, the bifacial gains with trackers.
All right, so Mr. Alex Lee, we have been talking about modules, but with the increasing power of modules, the selection of inverters become more and more important actually. So what factors need to be considered when it comes to inverter selection?
Yes, the main purpose of selecting a suitable inverter is to decrease the LCOE. As we know, there are 3 main points which will affect the LCOE, which are the CapEx, the OpEx, and the energy yield. From the CapEx side, the block design is very important. We always provide the support to our customer to find the most cost-saving design. From the OpEx side, it requires the inverter to have a good productive warranty, and requires the supplier to provide the fastest service response. And from the energy yield side, for sure, it requires the inverter has a good performance in its lifetime. So in an easy conclusion, the good product most suitable solution and promote service response and the good performance are the key factors which will need to be considered. Thank you.
All right, thank you. So the next one is still for JA Solar. So Mr. Monsoon Wang, you may have mentioned a little bit in your presentation, but we just want to know more specifically, how does the 11 busbar and half cell technology improve the module power and reduce the LCOE?
Okay, let me explain this for you. First, the half cut technology is quite mature, so you know we get a lot of benefit from the half cut cell technology. So first, you get higher module power output. You can lower module working temperature. You can lower hotspot temperature. You will get the more energy yield when the module is halfly shaded, partially shaded. So that's for the half cut cell technology. So for the 11 busbar adapted in the 182 millimeter cell, so JA Solar is the first module manufacturer adopting 11 busbar in the 182 cell. So we find a lot of advantage for our 11 busbar design. The first is the 11 busbar design increase the module cell efficiency, also decrease the cell cost, since we may use less silver paste, but we get higher efficiency. So also we get higher module power output and better module reliability performance. For example, with 11 busbar design, we get less micro cracks in the mass production line. We'll get better performance during the reliability test, such as TC test, also compared with TC400 test, we get better, we have less energy loss compared with 9 or 10 busbar design. Also, finally, it's also very important we find that 11 busbar brings, so drops the module working temperature, and also it brings higher energy yield performance. We also made some comparison. So the 11 busbar can increase the module energy yield performance about 0.5 to 0.8%. So overall, we have a lot of advantage on the 11 busbar technology. Thank you.
Yes, I guess that's why JA Solar has always been very professional. Yeah. Mr. Alex Lee, with the technological progress and continuous improvement of module power, the system also puts forward a lot of innovative requirements for inverter manufacturers, such as energy storage. So what development trends do you think that inverter technology will have in the future?
Yes, that is a good question. As I just mentioned in my presentation, from this year, more and more project binding requested the PV inverter have the reserved interface for the energy storage system. Generally speaking, the development trends of the inverter are coming from three parts: the DC side, the AC side, and the inverter itself. So from the DC side, the inverter needs to adapt to the large format PV module and has the energy storage interface to store the redundant energy. From the AC side, the grid requires the inverter can work normally to support the grid. And from the inverter itself, for sure, the inverter is required to have the lower system costs, the higher energy yield, and which is easy to maintenance. So the new trends like the energy storage interface, self-constructed grid, higher output power, and modular design will be popular in the near future, just like our new generation central inverters, FG1100 UD. So thank you.
Yeah, thank you. So the next one is still for next checker. Mr. Sugandhi, it is known to us that your True Capture smart control system can enhance the energy yield by up to 6%. How do you achieve that? And have you commercially deployed the system?
Thank you, Shannon. So let me answer the second part of the question first. So True Capture today is deployed in over 11 gigawatts of projects worldwide. So that's a good base. It's been under operation for over 3 years now. So that, I think, answers the question about deployment. How does it work? So essentially, normal tracking algorithms, they are taking the position of the plant, and they're taking into account the position of the sun, and that's how they're tracking the movement of the sun. What those algorithms don't account for is the undulations or variations in height on the ground. So let's say your site is undulating, and there will be variations between the heights on the ground, and the modules are at different heights. So the tracker is not really adjusting for those variations, and in effect that's causing shading at the plant level. So what TrueCapture does is it actually builds a virtual model of the site, and along with the position of the sun and the position of the modules, it's also taking the height of the modules into account, and then adjusting the tracking algorithm real time to ensure that there's no shading on the module. And that's one part of the TrueCapture. The second element of TrueCapture technology is the diffuse light tracking, where in case the site witnesses any diffuse light, then instead of trying to be normal to the sun, the tracker then adjusts the algorithm to become more flatter and capture more isotropic radiation, thereby enhancing the yield. So with a combination of these two effects, we see plants can achieve up to 6% more energy with TrueCapture technology. Thank you.
True, that is absolutely a successful, invention, and thank you. The last question is for Mr. Nader. Let's just see from a very big picture. The proportion of overseas market is actually a very big part of the sales of domestic leading enterprises, the Chinese enterprises. So do you have any specific strategies to help these enterprises get more market share?
Well, so for instance, what we can offer to let's say to market the efficiency of certain modules that are currently larger and with higher output, what we can offer is outdoor testing. So, and we have different outdoor testing facility in different regions. For instance, we have in Germany, that's the standard climate region. We have in India, it's more humid. We have in Saudi Arabia, it's more desert. And we have as well in China. So what we can offer to these manufacturers is to test their modules outdoor under real weather condition for different periods of time. So the minimum would be 3 months, but it can go up to 1 or even 2 years, and then provide information from these outdoor test facilities. And this should enable the manufacturer to showcase the efficiency of their modules under real weather condition. And all of these outdoor test fields that we have are standardized in the sense whether you put your modules in one region or the other region, we are using the same equipment and same procedure and same analysis. So you would get as well a comparison how these same modules can behave under different weather conditions. And so you can, so these manufacturers would be able as well to target different markets, let's say Europe or the Middle East or India, with this type of data that we can provide from our outdoor testing facilities.
All right, thank you very much. Well, I guess that's about all the time we have for today. And once again, thank you to all the presenters and audience, as well as JA Solar for making this discussion possible, and Sungrow, Nextracker, and TUV Rhineland for all the efforts you have done to make this planet a better place. We wish you all the prosperity for your business, but more importantly, take care of yourself, because good health comes the first. And since the pandemic is still ramping out there in the world. So for more questions, you can visit jasolar.com or contact us whenever you want. And thank you very much, and hope to see you soon in person. Stay safe. Goodbye.
Bye.
Bye.
Thank you.
Bye.
Bye.
Take care.